we have looked at the situation of having a graph like this and drawing, if this is f of x, we're drawing the gradient function. How does that work, guys? What sort of graph am I going to have? A parabola. If this was a parabola, I would have, not quite, yeah, a straight line. And if I had a straight line, I would get a horizontal line, right? We learned that. We also learned that if this is a positive cubic, we'll get a positive parabola, all right, because it starts increasing, which means we get a positive parabola. What was the last thing we learned? We learned that, see if anybody can come up with it. That this point tells us something. It comes down to here, doesn't it? So this is a positive cubic. We're going to have a positive parabola going through these 2 points as our gradient function graph. So that's f dashed of x. So if we were given a parabola, what are we going to get? Good. If we were given a straight line, we're going to get a parabola. And if we're given a horizontal line, we're going to get a straight line. So it's just exactly the inverse, like everything in differentiation, anti-differentiation, it's the opposite. We're going to try and find the original function. So, some things to remember. If we've got a quadratic, it came from a cubic. If we've got a line, it came from a quadratic. If we have got a horizontal line, it came from a diagonal line, we're going to call it. So that's the first thing to realise. So we look at it and start to make some decisions. The second thing is that if it's positive, then so will be the original. So positive cubic, positive quadratic, positive quadratic, positive slope on our straight line. All right? Positive slope on our straight line, positive value of our horizontal. It'll be above the line. Same thing with the negatives. And the last thing is, in this case, our maximum and minimum told us where our x-axis cuts were. So turn that around. X-intercepts tell us where our stationary points are. That's our maximums and minimums. It's gracious me. Okay, so let's have a look at a couple. Let's start with the easy one. If we've got this, diagonal straight line, tell me about it. What are we going to have? This is f dashed of x. No, I'm not going that way, I'm going the other way. I'm going to get a quadratic. It's got a positive gradient, so it's going to be a positive parabola. And it's going to have a good minimum point, because it's a positive quadratic, at this point. All right? So we go, and there's going to be, now the problem is it going to be this positive parabola, or is it going to be this positive parabola, or this one, or this one? We don't know. And that's where that C that we've been finding comes into it. So in this particular question, usually So if they didn't give you a point, any of those would be correct. But they are likely to say that f of x, they're likely to say find f of x going through 0, 2. All right? So 0, 2 is around about here somewhere. Now we have to have one of those graphs. So looking at those graphs, it looks like this one might be approximately our right answer. All right? Because we have to go through that point, and that one can't go through that point. But there's probably quite a few other ones I could make it skinnier, and it would still go through that point. But I have to hit that point. So if they wanted to make this a really hard question, they might say something like this. Find f of x if it goes through 1, 4 and 2, 0. Okay. And then they'll give you a graph. And we're going to go here. All right. So that's our f dashed of x. What do you think the first thing we'll do is? We're going to plot those points. We're going to put them on. All right. So I want to say that's 3 and -1. So I've got 1, 4 and 2, 0. My answer is going to go through those 2 points. What kind of graph am I drawing? A cubic, right? Quadratic changes to a cubic. Parabola to a cubic. These are my maximum and minimums. Is it positive or negative? It's positive because it's a positive parabola. It's going to be a positive cubic, which means it goes, yeah, starts from down. Up, down, up. All right? So I have to go with a maximum on that line and a minimum on that line through these 2. So I'm just going to mark 2 points because it doesn't really matter where they are. I need to hit those 2. So I'm going to go up to there, and I'm going to come through these ones, up to here and off. So I've got the maximum and the minimum. I've hit these 2 points. My cubic would become a parabola. It's not too hard, but